Hey everyone, welcome back. Hope you had a good Thanksgiving. Continuing on with our triangles. Today we'll hopefully kind of simplify the proofs a little bit, make them a little easier to understand what we're trying to prove um, from our givens and stuff, and then we'll just have to kind of go from there. So, start with a warm up. Kind of think back to what we learned last week. Try to figure out what the angles measurements for number one are, and then find x and y and the sides of the triangles for number two. Enter your answers in the Edpuzzle, and then come back. Okay, so the first one we're going to say we have our ABC is congruent to DBC, so we know the triangles are congruent, so that means we know all the angles and all the sides are congruent. We're just looking at angles here. So they've told us angle ABD, which is the big angle on the triangle on the left. The big angle of the triangle on the left is 110 degrees. That's actually going to equal the big angle on the triangle on the right, so angle BCD would also be 110. They also tell us that angle D is 20 degrees, so we've been told the two of our angles in the triangles equal 130 degrees when we add them together. If all the triangle angles have to add up to 180, then we're left with the other angles being 50. Hope everybody was able to get that. The next one, we're told those two smaller triangles from the big one are congruent, so QSP is congruent to QSF, or QSR, sorry. And we're asked to find X and Y and then the side measurements. So the first thing we know and we can kind of look at is if all their triangles are congruent, all our sides are equal. All our corresponding sides are going to be equal. So that 2x side is going to equal 3y plus 8. Really can't solve anything there. And then x is going to equal 2y. So that's what we're going to use. We're going to use x equals 2y, plug that into the 2x equals 3y plus 8, and kind of go through and find out that y equals 8. Sorry about my 8 there on the y equals, but that definitely is an 8. So then that tells us that x is 16. So we know the bottom sides of the two triangles are both 16 units. 2x is 2 times 16, so that's 32. So the sides of our triangle, the hypotenuses of our angles there, are 32 degrees, or 32 units. So hopefully everybody was able to get that. Okay. So like I said, we learned last week that the triangles are congruent if and only if all the sides and all the corresponding angles are congruent. So we need to have all sides congruent, all angles have to be congruent for the triangles to be congruent. From that, we're able to kind of build on some properties and some postulates to help us simplify triangle proofs. One thing we do need to know before we start is the triangle rigidity property. What that tells us is a triangle can only have one unique shape if we know the lengths of all its sides. So if you were told the triangle has measurements 12, 13, 14, we know there's only one triangle that's going to equal 12, 13, 14. There's only one way we can draw that triangle. Same way we know if we have sides of 3, 4, and 5, the only way we can draw that triangle is it has to be a right triangle. Because we know from the Pythagorean theorem and the rules that we know it's a 3, 4, 5 right triangle. It's a special right triangle. So just remember that as we kind of go through. So we really only have to prove then from what we've learned that if 3 sides of one triangle are congruent to 3 sides of the other triangle, then the triangles are congruent because given our side lengths, the side lengths to be congruent, for the triangles to be congruent, the side lengths have to be equal. So if we know the side lengths are equal, we can only draw one shape from that. So any triangles drawn with those side lengths, they're always going to be congruent. Hope that makes sense. So from that, like I said, we only need to show, we don't need to show angles are congruent now. If we can show the 3 sides are congruent, we don't need to show the angles are congruent. We can just go right to the triangles are congruent if the 3 sides are congruent. Sorry for the typo. We're going to prove, not prove. Okay, so I have a proof. We're going to kind of walk through this one together. Then you'll work on the next one yourself. So we're told that AB is given as congruent to DB. We're also told that C is the midpoint of segment AD. We have to prove that those two smaller triangles are congruent. So we start with our givens. AB is congruent to DB, given. Likewise, C is the midpoint of AD. That's our given. So from that, we know now we're trying to prove the triangle is congruent. We know one side's congruent. Told us that. We can look at the picture and know that we're probably going to be able to say that BC is congruent to BC from the reflexive property. That's line 4. I'm going to go with first, though, is that AC is congruent to DC because that flows better with the midpoint formula, the midpoint theorem, because that's the reason. Because C is the midpoint of AD, we can say AC is congruent to DC because of the midpoint theorem. So then angle 4, we have BC is congruent to BC from the reflexive property. We've proven now, we've given one angle, one side's congruent, proven the other two are congruent. So we can say the triangles are congruent by the side postulate. You can list postulate if you want. You don't have to. Just SSS lets me know you know what you're doing. Okay, like I said, you're going to work on this proof. It's only 4 lines. You can do everything you need to do in 4 lines. So take a few minutes, plug that in, give me your answers in Edpuzzle that I asked for, and then move on to the next stuff. Okay, so we were given our 2 statements. RS is congruent to UT, given. RT is congruent to US, again, that was a given. So we're even the diagram and the words, we know they're given. We're kind of looking at our parallelogram. We see that our triangles share a side. So TS is congruent to TS. That's our reflexive property. We've proven all 3 sides are congruent. So the triangles are congruent from the SSS postulate. Does that make sense? Awesome. Another new postulate we're learning is going to be side angle side. But before we do that, we need to know that the angle that's formed by 2 sides of a triangle, we're calling that angle the included angle. So where the 2 sides of a triangle meet, that vertex, that's the included angle. You'll see it in the picture. I'll talk through in the picture. The side angle side postulate tells us that if 2 sides and then that included angle of one triangle are congruent to the 2 sides and the included angle of another triangle, then that triangle is going, those 2 triangles are going to be congruent. The reason we can say that is the included angles, the sides opposite those included angles are going to be congruent. They're going to be the same size because it's just kind of the way we know that the angle measures are congruent. We know that 2 sides are congruent. It kind of falls back into the 3 sides are now fixed. We're not given that 3rd side, but we know that it's fixed based on our the triangle rigidity theory. So that's why we're able to jump right to this by side angle side things being proven true. So our example, are those 2 sides congruent? 2 triangles are congruent. We see that AC is congruent to DF. ED is congruent to AB. We're including the angle between those 2 sides as well. So now we know from triangle rules, I think we'll get into a little bit later on, that because the angle measurements are the same, that makes side BC and EF congruent. They have the same measure. So yes, those triangles are congruent. Take a few minutes to kind of look through these 3 pairs of triangles and determine whether they're congruent by side angle side. And then write your answers into Edpuzzle. Okay, so the first one, yep, they're congruent. We have 2 sides with an included angle. The right angle is between the 2 sides that we're told are congruent. So yes, we can say those are congruent. We look at the next one, triangle XYZ. We have an included angle there between the 2 congruent sides. But in ABC, we don't have the included angle. So those are not congruent. And the last one, again, we have a shared side. So that's congruent. We have the 2 outside parallel lines are congruent. SR and PQ, they tell us are congruent. Our angles are between those 2 sides. Angle 1 and angle 2 are included angles. So yes, that is congruent. That makes sense. Okay. So now moving on, the next thing we need to know is we talk about the included angle. Well, the side between 2 angles of a triangle is called the included side. So we've had the side angle side postulate. Now we're going to have the angle side angle postulate, which tells us that if 2 angles in the included side of one triangle are congruent, then the 2 angles and the included side of another triangle are congruent. So we look at our picture, our diagram. We have angle A is congruent to angle D, angle E is congruent to angle B, and side AB is congruent to ED. It's an included side, so we can say that those 2 triangles are congruent. Here's a quick example. I want you to take a few minutes. Tell me, are those, or can we say that those triangles are congruent? Okay. You should have said yes. The angles that we're talking about are the corners. It's the same corners of the rectangles. We see that BAC is congruent to DCA, and then DAC is congruent to BCA. So our shared side is the side that's congruent. The shared side is the included side for both triangles. So those two triangles are congruent. Does that make sense? Okay. Gonna work through a proof here to kind of go through and see to talk about our next postulate. So here we have a triangle. It's a kite actually. The shape is called a kite, but it's split up into two separate triangles. We're trying to prove that ADB or ABD is congruent to CBD. So we're gonna go through, take a few minutes. If you want to try to work it out yourself, awesome. But I'm gonna work through with you if you want to do that. So we start with our kind of givens from the example, from the picture. We have angle A is congruent to angle C. We see the one arc in each angle, so those are given. We also see that angle ABD is congruent to CBD. Again, we see the two arcs in the corner there for angle B's. So that was our other given. So now what we can actually say too is that angle ADB is congruent to angle CDB by the three angle theorem. The third angle theorem, the third angles have to be congruent if two angles are congruent to a triangle. But from the angle stuff now, we really can't prove that those triangles are congruent because angles don't do it for us. We haven't proved any of the sides are congruent. What we can look at though is we see that the true triangle share side DB. So DB is congruent to DB. That's our reflexive property. So we have nothing there that we can kind of say any of the other sides are congruent, but I can say that triangle ABD is congruent to triangle CBD from the angle side angle postulate because I know we proved that angle ADB is congruent to angle CDB, and we were given that the two angles at that point B are congruent, and the side shared between them is the included side, so we can say that's congruent. What I did that for is this kind of leads us into their next theorem, which is the angle-angle side theorem. So I'm going to step back one slide for a minute. And if we look and see in our diagram, we were given angle A, we were given A and C were congruent, we were given that ABD is congruent to CBD from our picture. So then if we have two consecutive angles and we can prove that the next side is congruent, then we can say that everything's congruent, which we're able to do with that reflexive property. So if two angles and a non-included side, it doesn't have to be the next one, it's just one of the non-included sides of one triangle are congruent to two corresponding angles and the corresponding side of a second triangle, then we can say those two triangles are congruent. So we have the angle side angle kind of works similarly angle side works similarly to angle side angle. It's just the order is a little bit different, and the order does matter. So here are a couple of problems I want you to kind of look at and see if you can kind of see, are we able to prove, using all the forms and theorems that we kind of know right now, can we say that these triangles are congruent and then justify what you said? So again, we're going to have you answer your in the Edpuzzle and then move forward. Okay, so for number 3, we said they tell us in the word problem kind of thing that side AB and CB are both 3 feet long, so those sides are congruent, they have the same measure. They also, in this number, example 3, told us that D was the midpoint of AC, so that basically tells us that AB is congruent to DC. So we have two sides are congruent. We look at our triangle, the sharing side BD, so that tells us BD is congruent. So yeah, we can say those triangles are congruent because we can say that the 3 sides of each triangle are congruent. The triangles are going to be congruent then from the side theorem. Make sense? Awesome. Number 4 is a little trickier. Still the same information. AB is congruent to CB, they're both 3 feet. Then they tell us that AC is congruent, angle A is congruent to angle C. So I know that. I know those sides are congruent. So now there's really no other information we have. We can say that BD is congruent to BD, but we really don't have a side-side angle postulate. We can't do it based on that. So we can't prove anything based on what we have. If they told us one other piece of information, they told us BD was a segment an angle bisector, then we could do something, but they didn't give us enough information for number 4. So if you kind of get that one wrong, that's okay. It's always talking about the pictures don't really do justice. They're not the scale, so you can't just assume stuff from the picture unless you're told. And then one last thing I want to talk about today is if a triangle has 3 congruent angles, but you don't know anything about the sides, all you can say if you have 2 angles that have congruent, 2 triangles that have congruent angles, all you can say is that they're similar. You can't say that they're congruent. The only thing you can say is they're similar. And what that means, though, is that then you can form ratios between all the sides of the triangles. And there's all sorts of problems we're going to work on with algebra in geometry here with that type of information that we're able to say, okay, similar triangles, now we're going to be able to find some measurements that way. But you're never going to be able to say, just given that the 3 angles of the triangles are congruent, you're never going to be able to say that the triangles are congruent. You'll only be able to say they're similar. And like I said, we'll see that a little later on in the unit. So I hope that made sense to everybody. The homework problems are definitely going to kind of reinforce a lot of this to make sure we all understand it. But these postulates that we just learned make triangle proofs a heck of a lot easier, which then make a lot of other stuff in geometry a heck of a lot easier. So everyone have a good day, and I will see everybody, talk to everybody tomorrow.